There's another question coming through in the chat. How would you know if the data has the information that will help you to predict what you want or not? Do you have pipelines to analyze it first?
Well, that's a great question. And it's we have a few things we do, but my answer to that question will kind of be largely depend on the problem that we are trying to solve, and it'll be different for each customer. But I talked about this digital twin building process, right? And this was something that came up way earlier on. Like without good quality data, this digital twin is not basically buildable. So how do you know that without actually undertaking the exercise of building this, how do you know if you have the right amount of data? So several approaches of solving this. Like step one, starting from the business, you make sure the sales get the right guidance, right? There is don't look at the sensor placement, look at the level of maturity you have with this customer. Are they, if we give them a feedback, do I ask to install a new sensor? Like a sensor will sometimes cost only $200 to install, and that will make a world of difference. Are they willing to do that? Is there existing data quality? Are you getting at least one data point in 15 minutes, every 15 minutes? Like this, so there are like fundamental checks that you can do, even by like a non-technical sales qualification process, or like even before you start thinking about model, start thinking about even data analytics on this. And then you only qualify, like in our case, we only qualify the customers who we think has like a certain initial quality check mark. And it goes into like domain experts. Domain experts are like, and these are there in every data science company. These are non-data scientists who are coming from the industry, right? In our case, this is water quality experts, wastewater industry experts. They have been taught a certain degree of data analytics, and they look at data, sensor placement, they apply all of this, their expertise to this, and they do an additional layer of filtering. Now, the first level of filtering is the cheapest. The second level, it starts getting expensive, but a data scientist is the most expensive hire you can make. Like, but we need to minimize the number of bad customers reaching data scientists. If you get filtered out earlier, that's better. So we equip them with like these non-programmatic tools, like visually analyze data, things like that will ask for does the critical sensors have enough data? Are you seeing anomalies in critical sensors? Things like that, and they have another set of checklist. But sometimes some of the advanced data problems are only like figure out after you start building a model. You do some research engineering, you do an initial model, and you realize that it's not fitting, doesn't work, right? So in there, what we have tried to do, and we are not fully successful in doing that, but as you gain experience over multiple projects there, you can accumulate this knowledge into like an AutoML framework that so let's say I pick a process of flow collation. Flow collation is like a big tank in which you add some chemicals and gets suspended solids that gets on top of this tank, right? So then there are various flow collation mechanisms, or there are various models that gets built for this to reproduce this problem. And we kind of build that into an AutoML framework in which like each model gets tried one after the other, and a certain degree of hyperparameter tuning is performed, a certain degree of feature engineering is performed on all of this. And this is automated. This is before a data scientist applies his or her intelligence to this process. The automated, you see whether like a certain degree of quality is even correlation is even possible. Like what's your MAPE, what's your RMSE numbers. And this is even before, this is again before putting in like a lot of work from the data scientist, which means you can filter out a lot of things when you go through this set of steps. But sometimes things just pass through, and there were instances where we have spent the time and money only to realize that it just doesn't work.
And in those cases, you have to go back to the client and say, "Hey,
yes,
sorry.
Install the sensor for us." Well, no, we won't say sorry until we have given up on it. But at that point, we'll say, okay, can you get this more data? Can we wait a few more months? Can I collect a few more data before we can start modeling? Can you do this extractions on this? There are scenarios that we have not seen these systems operate in. So can you add a little more chemical, a little less chemical, and then can we? It's all step testing, right? So then can we observe the resulting data points so that we can capture that dynamics in the models, like all kinds of things we do to improve the model building process over time. But ultimately, if none of that works, yes, you have to give up.